So in this episode, we will talk about the bi-temporal functionality in the Datavault Builder. And so you can follow along very easily. We have created a sample file just with an account, a date, and an amount. And we will do changes to that, and we will do backwards correction to that and see how this is stored in the Datavault Builder. So the first thing we need to do is we always create our target. So I will say I want to load here account. That's something related to the customer. And this kind of functionality we use very often in banking, insurance businesses. And what we will do here now is load our data. I connect here to a CSV file source system so we can simulate how the data changes. And I will take the account balance file that we have seen in the text editor. I will add it, and now I will indicate that the date is our external timeline by marking it as inscription time. It could be a timestamp. Here we have only the date. That's perfectly fine. So we'll only use the date because here it's the extraction date. This needs to be spelled correctly. And depending on the database that you're using, either lowercase like on Postgres, SQL Server, or uppercase on databases like Oracle, Exasol, or Snowflake. So we'll convert here into timestamp. And now we get this little clock. This little clock is indicating we have external timeline, and the data was now loaded, and it looks the same as usual. We get the row ID, and the date was converted here into a timestamp while loading. And difference comes when we go here to the vault. If I add here a hub load, select this table, I see that my timeline is missing because the timeline will be taken into consideration automatically just by adding the ID. It will tell me that it's unique, but it's only one row. So before we go on, let's see how it behaves if we return here to our text editor. We will add the second line in here, and it will be for the same account. But for the next day, it will give us indication of 102. So if we try to load this into a normal data vault concept without taking care of anything, this will create a problem because we have now two rows in one batch for the same business key. So let's go in here, let's add the load again, but it will tell us that this is fine because it knows it's two different points in time. So we could have a look at it, and we see the two rows here. We would see the two different amounts, but it's fine. It knows how to store that. We skip here as well the business key section. We just add the hub out at the satellite automatically, and we can start loading. And now it will create a bi-temporal satellite, or has already created that. So it will store the load time. When did we got information about these two rows, but it will store as well the business time and differentiate between them. And in fact, that's exactly what we see now here in the satellite. So we have two times. It was loaded into the vault at the same point in time. So we are fully auditable. We can say when we got knowledge about this information, but we see here as well at the end that it was meant to be for the 1st of March and the 2nd of March. So now we have loaded the data. So let's go here to our output section and select what we want to see. And in the first thing, we want to see maybe just the as of now information. So what is the latest information regards to business timing for our account? So we can put here in the amount, and hopefully if we did everything right and we have a look here, it should be 102. So let's go back here, the web, let's store that and let's review it. And that's correct. The latest information of the account balance was 102. If we want to see the full history, we just create here as of then object, and we do this here by selecting std type 2. Now it will create a pit table join everything together. Yes, we have now only one satellite, so it's not that difficult yet, but it would extend it later. If we want to join it, it would create several pit tables if necessary to join between different objects in a temporal perspective. And here we don't have any output because the pit table wasn't loaded yet. So we can start it either here manually, or we can go to the job section, just start our job. It will load everything in the right order, including the pit table. And if we return now here to the interface after the load completed, we preview the data, we will see now the history. And we see now the history based on the business timeline. So from 1st March to the 2nd, it was 100, and then it became 102. And that's all that you need to do. Now everything is set up, and now we can just show that it works for all the different use cases. So let's go maybe and correct something backwards and say, no, this was here already 101 one day before. So we go back here to the web interface, we reload our job, and that I don't need to switch between the different views. I just open here a second view, so I can keep this here open at the dimensional model. I can go back here to the job and start it, see when it completes. And the first thing I do is I go into the satellite. And so here, this is row 2 and row 3. We don't display here row 1 because it was replaced with a correction. So now we see here that it is 101 for the 1st of March. But if you go to the database, you will see that all of the rows are still there. So let's go now here to our as of now interface. Nothing changed here because the latest information that we loaded didn't change according to business times. If we go here to our STD type 2 history, we will see now that it corrected the record at the right time. So this is some basic functionality, but we can continue with more complex cases. So let's assume that it's redelivered every time, every day. So for the 3rd, for the 4th, for the 5th, and for the 6th, this information is redelivered. But it would be really bad if we would store it exactly that way. So what we do is to do a compression. We recognize that for the different business day that the data is arriving, we only need to store it once. But if we would do only that, we would have trouble identifying later on backwards correct changes. Because if now, like on the 5th of March, correction happens, we haven't stored this information that we received back then. It would be really difficult. So what we do in here, that we store here as well tracking objects that we don't display in the data model because these are only technical objects, but they are there. So let's have a look on here in the satellite. We have 4 rows, but only 3 of them, or no, we have only 3 rows because after this information, nothing changed. So nothing new in the satellite as well. In the output, if you look, nothing changed so far. And we know still this information was covered by what we got delivered. We stored that in the tracking object. And why is that necessary? Imagine now that somebody goes in and say, no, 2 days ago, it was 105. And now, if we wouldn't have stored it in a tracking object, we would say it was 102, then it changed to 105, and then it would stay 105 because we ignored these records. That's not the case. Let's test that. Let's go to operations, reload this information. And if we go back in here into the satellite, 2 new rows were added. One for the 4th where we did the change. Here, but this was only valid to the 5th because on the 5th we received already earlier this information that it still was 102. So now, even if we get backwards correction, all the necessary steps for injecting the records after that, if the history didn't change for all of the dates which already passed, is handled automatically. So let's look in that we see it as well here in our satellite. We have now 5 rows in total. The first one was corrected, so it's not visible here. But we have here received first information 102, then 101 was the correction for the first day. Then we received here at the same time the correction for the 4th of March plus the injected record for the 5th of March. So that we see here now that this here is reflected correctly, this here is reflected correctly, and this here. Now you say, yeah, but you re-delivered this information, so that's not that difficult. So let's do the same here, and let's put it 104, and we don't deliver the 6th anymore. Doesn't matter, the tracking object will take care of that. So let's reload it. And we go back here into the satellite. The record for the 5th of March should get injected now because we changed here the record for the 5th to 104. So it needed to add the row for the 6th that we received already earlier, but it's not anymore in the file. And as well, if we go to the dimensional model, then you will see the right output. And yes, you can create all of this manually, but believe me, there are many use cases that we covered, tested, checked that data is compressed, even if you follow links, that is already covered out of the box, tested by many people, and we get feedback to even improve this kind of functionality again and again by all the clients using the same standardized functionality in the market. Thank you.